everyone, in this video we're going to be looking at calculating the volume. Specifically, we're going to be using a disk method, which means we're going to be rotating some function around our x or y axes, and towards the end we're going to look at doing it around some other vertical or horizontal plane. So what we're talking about here, so different from the last section, if you just watched that, in that section we were given some shaded region, and we were told that was the base of some object, and then we knew what the cross sections of that object look like. This is a little bit different in the sense that what we're going to be doing is we're going to be just taking some function and then we're going to be rotating it around an axis. And so what's going to happen is we're going to create, and it's going to be a bit hard for me to go down because it can't go all the way down, but you can imagine that we're going to create a bunch of, again, we're going to have cross sections, but in this case, it's going to be cross sections that actually, that's not very good right there. At the top should be none, but we're going to have a bunch of cross sections. And because we're talking about rotation, we're going to create a bunch of circles. And it's going to feel very similar to the last time where we're just going to use our circle equation, except we just have to figure out an expression for our R value. Now, the most basic one is just looking at our function where we're rotating around the X. Our R value is literally just going to be whatever our f of X value is, because you can see from this point all the way down, if I'm creating a circle here by rotating it all the way around, that this rate here is going to be the radius of that circle. So that's the easiest. If we're rotating with respect to y, it's going to feel a little bit like the inverse, where we care about what our y values are for that given section. And so we will rewrite our equations with our functions with respect to y. And then from there, the calculus is pretty straightforward. And again, this is just a better rendition using GeoGebra. What's happening here? We've got I've just linked two tools for you to kind of play around with and look at what it looks like, as you change your domain and change, you can even change your function as to what it looks like as you rotate around the X or Y plane. But at the end of the day, this is going to be sort of the template that we're following through, where we want to figure out what the area of each circle is. And so it's going to be pi r squared, of course, is our base formula. And in the case of rotating around X, well, it's just our f of X is going to be R. So we're going to square that and then, look at what our indicated endpoints are and integrate on that domain. And if we're rotating around Y, again, we just have to rewrite our function in terms of y, and it's going to be the exact same. Now, usually, you'll see me kind of make note of what my points are, my x1 and my y1 and my x2 and y2, so that I can switch between them, because there's a few questions where we're just going to kind of double dip and do it once around the x and once around the y. So let's dive right in. Let's do some examples. So here we've got f of x equals to x squared, and we want to determine the volume if we rotate around the x-axis. So I'm just going to keep in mind that, okay, pi r squared is going to give me the area of each of those circles that I'm going to create as I rotate along each point on that function. So, and I'm going to create a bunch of them. I'm going to create an infinite amount. So I want to use integration to help me add them all together. So I'm going to integrate along 0 to 2 here, 0 to 2. And instead of writing pi r squared, I'm just going to take out my pi because it's a constant and write it out front. And then my r in this case is always just going to be whatever f of x is at each single point there. So I'm just going to use f of x as my stand-in. So f of x is going to be my r value. And then, of course, I'm squaring my r value and differentiating with respect to x. So that's going to become pi from 0 to 2 is my integral, and then x to the 4th power, and I'm differentiating with respect to x. And then I can actually perform the integration. I can get x to the 5th over 5, and I'm going from 0 to 2. And then at this point, I'm just going to take that 2, plug it in, and then take the 0 and plug it in. But I don't really have to do that because it's a little bit redundant. And hopefully you can see here that we're going to get 2 to the 5th power over 5 pi minus 0. So that doesn't change anything. And that'll be the volume in whatever units are needed for this question. And when you do that, you end up with that right there as the answer. So let's try doing around the y. Feel free to pause if you think, you're starting to get comfortable with this and you can see what the pattern is. So if I'm doing this around the y, then I need to rewrite my function in terms of y. So this is just going to be the square root of y is equal to x. And so again, I'm going to go from, I'm integrating from, now I got to be careful here because here I was going from 0, 0, and then to 2, 4. So I care about, I'm rotating around the y here. So I want to, I should say I'm revolving around the y. No, I'm rotating. You rotate around a point, you revolve, regardless. Excuse me. you want to use your y points as your reference, because those are going to be your function is now f of y, or f inverse of x. So I'm going from 0 to 4, and it's going to be the square root of x all squared, and here's my pi, square root of y, and then dy, and so pi from 0 to 4, and now this is nice and easy. Square root of y squared is just going to be y dy, and then that's just going to give me pi y squared over 2 from 0 to 4. And again, you're just going to plug the 4 in, plug the 0 in, and evaluate. And when you do, you'll end up with 8 pi. So let's go to the next question. So here we've got a little bit of just a tougher situation here. Not too much harder. It's just going to be the same steps, but the function looks a little bit more complicated. So I'm just revolving here, around the x. So I'm going to write it as, just follow my same steps out, except I'm not going from 0 now, I'm going from 1, so that's my bad for writing that. So I'm going from 1 to 2, and I want to write the pi outside, and it's going to be r squared. My r in this case is going to be whatever the f of x is, so x minus 1, all squared, differentiate or integrating with respect to x. And so I'm able just to integrate right away here. And so this will give me x minus 1. So let me actually take a step here. I'm kind of rushing. Let's try that again. From 1 to 2, and then I've got square root x minus 1 all squared, and pi right here. It's about to go down a deep dark hole there. So this will be from 1 to 2 pi. When you square this, you just end up with x minus 1. There we go, dx. And then that's going to be pi on 2 x squared over 2 minus x, close bracket, and then you evaluate from 1 to 2. And again, this is just a simple, and I'll actually substitute this one in, but I'm not going to spend some time evaluating or doing arithmetic here. So I'm just going to do pi and then big bracket. So 2 squared over 2 minus 2, close bracket, minus, and then 1 squared over 2 minus 1, close bracket, big bracket, and then you would evaluate that. And when you do, I think you end up with 0.5, looking at it, 0.5 pi, yeah. I got my pi there, good. All right, so let's clear this, and let's do it around the y-axis now. So again, if I'm rotating around the y-axis there, then it's going to create, hopefully you can see there that initially my radius is always going to be at least 1, and then get bigger and bigger and bigger as I go here, kind of like a volcano, I guess. So I got something that looks like this. And so what I'm going to do is I want to rewrite that in terms of y. So here I have y equals square root x minus 1. I'll square both sides, y squared, and then add 1 is equal to x. So here's all my radii here within that given range. And so I'm going to integrate from, where am I going from here? So again, I just want to pay attention to what the inverse would be. So 1 and 0, and then 2 and 1. So I'm going to go from 0 to 1 now. And I put that pi on the outside because it's pi r squared. And then this is going to be a y squared plus 1 all squared dy. Want to properly expand that out before I integrate. So 0 to 1. So y to the 4th plus 2y squared plus 1 dy. And then, of course, I would integrate. And that's going to give me pi on 2 y to the 5th over 5 plus 2y cubed over 3 plus y, close bracket. And I'm integrating along from 0 to 1. And again, you would plug your 1 in, plug your 0 in, but you don't really need to do that, and that'll give you your final answer there. So let's go to the next one. Let's do one more for posterity's sake here. So we want to rotate around the x. So again, I'm just going to imagine what's happening here. I'm rotating this bad boy all around my x, creating something that looks like this. And so in order to find the volume, I'm going to integrate from, what do I got here? From 1 to 3, 1 to 3, and put the pi on the outside, and then this is going to become negative x squared minus x all squared dx. And then I'm going to just follow along simplifying. So pi, 1 to 3, and mental math. So x to the 4th, x cubed, it'll be positive plus 2x cubed, and then plus x squared, integrate with respect to x. And then I'm going to actually integrate it. So I'll end up with my brackets there. X to the 5th over 5 plus 2x to the 4th over 4 plus x cubed over 3. And then you're integrating along 1 to 3. And I would plug 3 in, and I would have to plug the 1 in as well because it's, I've got to take the difference, and this 1 will not eliminate everything like a 0 would. And then we'll end up with whatever that answer is with respect to when you rotate around the x there. When we're doing our y, this is a little bit tricksy because we're going to have to bust out some grade 11 math because we want to, we try to isolate for x here. Like if I just write this as is and say y is equal to negative x squared minus x, I'm sure some of you might forget, you might not know where to go. And so we've got to actually go back and use some of our grade 11 math. We're going to complete the square. Before I complete the square, I'm just going to divide by a -1 on both sides because I'd rather complete the square with a positive number. And so in order for me to complete the square, in order for me to get a perfect square here, I have to ask myself, okay, what constant do I add in? So I can just do x plus something all squared. And so I'm going to halve my coefficient and then square it. So half of 1, because I've got 1b here. So half of 1 is 0.5. 0.5 squared is 0.25. So now I have this lovely perfect square trinomial, but I can't just add something into an equation. Otherwise, it wouldn't balance out the equation. So as soon as I take time to write plus 0.25, immediately I'm going to minus 0.25. So I actually haven't changed the weight on my right side here. So I can factor the first 3, or I can write it in factored form. And so that's going to be x plus 0.5 minus 0.25. And I've completed the square. And now I can actually solve for x. So I'm going to get 0.25 minus y. I'll square root while I'm doing it, and I'll minus the 0.5 all in one breath and step. And now I've got my isolated x, and I've written the equation in terms of y. So I'm going to integrate from -2 to -12 to -2. That's how numbers work. And here's my function, 0.25 minus y minus 0.5. Ooh. And I want to square that bad boy on dy, and can't forget the pi r squared. And this is a little bit tedious at this point. There's lots of room for algebraic errors, so I'll try to be careful, but I apologize if I make any. So I'm going to square this, so this will be, when I distribute it, it'll just cancel at that. Minus, so I'll get 0.5 of that and 0.5 of that, which is just going to add to 1. So I'll just have 1 of this, 0.25 minus y, and then 0.5 times 0.5 will give me positive 0.25 dy. And then I see that I've got 2 constants here that I can add together. So I'll get pi -12 on the -2, or from -12 to -2, and then 0.25 and 0.25 gives me 0.5 minus y minus, and I'll write this just like this, just to make it a little bit easier when I'm factoring to conceptualize what's happening, 1/2 dy, and I'm off to the races, ready to integrate. All right, so pi, and then this will become 0.5 y minus y squared over 2, minus, so this will be 0.25 negative y, 3 over 2, 2/3. Because it was negative, that must mean it started off positive. And then because when I do my chain rule out here and take when I take the derivative of negative y, or take the derivative of my inner function, I would just end up with -1. So I've got to make sure that it still ends up being -1, or a negative, I should say. And then it's from -12 to -2. And this would definitely be one where I would almost say, like, just substitute it in and move on to the next question, because that would get quite tedious to simplify. Even this much was quite tedious. But that's how you determine the volume, by rotating around the x or y plane. Take a crack at some of those practice questions. And if you have any questions or problems, shoot me an email or message on Teams.